Hi year 8s and welcome to our second lesson on equations, and today what we're going to do is start solving some equations using this technique that was introduced to you last year called backtracking. Alright, so let's get into it and just brush up on a few little pieces of terminology. So a review of expressions and equations. So they mean two different things, and this is the first thing to note. The following is an algebraic expression and cannot be solved. Right? So here it is here. Now, why can't it be solved? Well, let's just think about this, that this is an expression here, and remember that if you, the previous step, say, was 2x plus 5, what you would have done is collected up the like terms here to write 3x plus 5, and that really was as far as we can go to simplify the expression. Okay, we couldn't actually answer this question. So that's called an expression, okay, and we can't solve that. We don't know what x is. Now let's have a look at another one, and it's this one here. Now it's the same expression part over here, but all of a sudden we've got it equal to something, which is 14. So the following is an algebraic equation, and the reason it's considered an equation is because it's got an equal sign in it, and it can be solved. You may even be able to do this by inspection. So let's actually solve it. So what we can do here is have a look at this left-hand side, LHS, and this right-hand side, RHS, and see if we can solve it. That means that we need the left-hand side to be the same. Now remember, we use that with equals. That doesn't mean find the answer, it means the same as. So this left-hand side is the same as this right-hand side. So what is the value of x that will make this left-hand side the same as the right-hand side? Well, let's try x equals 2. Now I don't know whether this is right. I'm just going to inspect it to see. 3 times 2 is 6, 6 plus 5 is 11, and we know that 11 is not the same as 14, so that's wrong. Let's try x equals 3. 3 times 3 is 9, 9 plus 5 is 14. So the solution to this equation is x equals 3. That's the thing that makes it true. So that's what we're going to do today, is look at a method to allow us to do it without inspection. So the first thing the work will do is run you through these things called flowcharts. So we're going to complete the flowchart for the following. So here we're starting with 5, and what we're going to do is multiply 5 by 3, and that gives us 15. Then we're going to add 1 to 15, which gives us 16, and we're done. Alright, what about if the flowchart started with a pronumeral, an unknown, m? Alright, what we're going to do is add 5 to m, which is m plus 5. Now we can't work out an answer to that because we don't know what m actually is. And then what we're going to do is multiply all of this box by 3, which remember means it's 3 lots of m plus 5. So we're just going to put that m plus 5 in brackets and multiply it by 3. Now this wouldn't be wrong either if you wrote the multiply sign in, or if you wrote m plus 5 times 3, but that's the most correct way to write it algebraically. Alright, so let's step it up a bit now and use this method to solve a couple of equations. So use backtracking to solve the equation 4k equals 12. And I've said here, yes, you can probably do it without the flowchart, but go with me. So I can see that the answer is k equals 3. All right, I know by inspection that 4 3s are 12, and that will make the left-hand side the same as the right-hand side. But let's just draw up an equation. Now, what we do to draw up the boxes is we look at how many operations we've got, and this is just 4 times k. So this is one operation. So what we do is we draw 2 boxes, and this is the way we draw a box. What we're going to do is draw them like this. So there's 2 boxes, each separated into a top and a bottom. All right, so now what we're going to do is start putting in the things we know. So all we do is we start with the unknown. In this case, it's k, and we pop that in the box. Then we look at what happens to k to make it into what this left-hand side is, and it gets multiplied, so it's times by 4. So that will give us 4k. Alright, now in the box below, what we do is we put what it's equal to. Now we can see here it's equal to 12, so we're going to put 12 down there. Alright, the final step to complete the flowchart is to draw an arrow back to this box here and put a operation on this, and it's always going to be opposite to whatever this one is. So see how this is times 4? All we're going to do is put divide 4 there. Now let's do that. 12 divided by 4 equals 3. So now we've got the solution here. Okay, so now we can write down k equals 3. Right? Now, for some of you, that will seem like a long process, but that process is going to help us solve more complicated equations. Okay, so yes, you could do the simple ones just by looking, but the flowcharts help you when we're going to get lots and lots of terms. For example, if we're solving 3x plus 5 on 7 equals 42 or something like that, that one there is more difficult to solve via inspections. So that's why we're learning this flowchart method. All right, or backtracking method. All right, use backtracking to solve this equation. X take away 3 equals 16. So again, I can do this by inspection, and I can see that the answer is going to be x equals 13, but let's just draw up our boxes. Now we've got one operation, which is the subtraction, so we're going to draw 2 boxes. We're going to put in the first box the unknown. Now, an arrow leading to this box here. What happens to make it look like this left-hand side? We subtract 3. Which gives us x take 3. All right, now what we do is we put the answer into this bottom box here. Arrow goes back. What do we do? Well, it's going to be the opposite of this number here, which is plus 3. What's 16 plus 3? That's 19. So there's the first reason not to use inspection, is that I just got that wrong, and I'm not going to re-record this video because it's important to see. So I said that x was equal to 13 when I did it via inspection, which hopefully some of you were looking at the video and going, no, it's not, no, it's not, it should be 19. But anyway, there it is. The backtracking method got out the correct answer here. So we're going to answer this correctly. Not x equals 13, x equals 19 is the correct solution. All right, we're going to try one more example before you get down to it. So this one here is, again, using backtracking to solve it. But this one here is called a two-step equation, because what we have here is there's a multiply sign and a subtraction. So we've got 2 operations. Now that means we need 3 sets of boxes. So first set, second set, third set. All right. So all we do is we start with the unknown, which in this case is P, and we've got an arrow, and an arrow, and an arrow, and an arrow. All right, so now we start with P and we look at the first thing that was happened. Now we can see here that it was multiplied by 2 first of all. So this is times 2. So we're going to write that there. And then we're going to write out what P times 2 is, which is 2P. Then what happened was 5 was subtracted, so we're going to subtract 5 and write down 2p take away 5. All right, in this bottom box here, what we do is we put the answer, which in this case is 15. All right, now we can automatically fill in the opposite operations. So that's going to be opposite of subtract 5 is add 5, and opposite of times 2 is divide by 2. All right, let's try this. So 15 plus 5 is 20. 20 divided by 2 is 10. And that means that P must equal 10. Now we can check out this to see whether it's right, because we can put this into the expression on the left-hand side. 10, so if P is equal to 10, 2 times 10 is 20. 20 take away 5 is indeed 15. So this must be the correct answer. All right, so what you're going to do now is there's going to be a worksheet that's handed out. Now you need to do your work in your books, okay? And you need to draw, I'll try to write the letter D, draw the flowcharts, okay? Even if you can do it via inspection, I want those flowcharts drawn, okay? And again, I'm going to explain why, and you're going to see why when we continue to develop these equations and make them more and more difficult. So folks, good luck with that, and I'll check in with you on Tuesday.